Hi everyone, I'm happy to meet you all in this short video. So this video is about how to approach one of the important questions in paper 6, that is alternative to practicals, right? You know very well that one of the questions that has more weightage in paper 6 is planning an experiment. Sometimes the designing given by them is partially done. You need to finish the designing as well. So in this video we have example for both of them. Okay, so my advice to you, when you answer this question, you use following subheadings in your answer sheet. Okay, what are the subheadings? There are three subheadings that talks about the variables in your design, variables in your plan. What are the variables? Independent variables which you can vary in your experiment, right? And there is the other variable, dependent variable. When you vary the independent variable, how does it affect another variable, which is called dependent variables, right? And then the third variable, which is called variable to be kept constant, in other words controlled variable. So this variable should be kept constant throughout the experiment, so we control that variable. That's why it's also called controlled variable. Okay, and then the other subheadings to be included in your paper for answering these questions are the apparatus, method, table, analysis, conclusion, precaution, and additional details. Okay, so I will discuss about the later part of the subheadings in another video, right? In the second video. In this first video we are going to concentrate on how to write or how to find out these variables from the question. Yeah, so for this I am using two questions, one from Feb March 23 and another question is from the past year paper Feb March 22. Do not get confused, both of them asks you to plan a different kind of experiments. Okay, so the first one is from Feb March 23. Let's read out this question. A student investigates the motion of a ball through the air. All right. Now they ask you to help the student, right, to plan an experiment for him. So when you come across this word, plan an experiment, so keep a marker over there. Why? This is the aim of your planning. You are planning an experiment that will enable the student to investigate how the range of the ball depends on the angle at which it is launched. So later, at the end of this question, you are going to also write how you make conclusion from your experiment, right? So to write that part, to answer that part of the question, you need to know what is the aim of your planning experiment. So you need to have a marker at this point of the question, okay, where you have this keyword plan. So later, at the end of this experiment, your investigation is going to help him to find out how the range of the ball depends on the angle at which it is launched. So what is range here? The keyword here is range. Do I know what range is? If you do not know, no worries, it's already there in the question. The range is horizontal distance that the ball travels after leaving the end of the channel before it hits the ground. Imagine that you throw a ball, right? So if you throw the ball at different angles, that varies the distance that the ball reaches before it hits the ground, right? So you increase the angle, the range is going to get decreased. The horizontal distance that it travels is going to decrease, isn't it? So that's what we are exactly going to perform this experiment for, to find out what is the relationship, by changing the angle, how it affects the horizontal distance, that is the range of the ball, right? So what is the independent? By now I believe that you should identify what is the independent variable. What is the variable that you change here? Of course, the angle. So the independent variable here is the angle. When you change the angle of launch, which is affected, the range of the ball is affected. So what is the independent variable now? The first subheading, independent variable. What is the independent variable now? The independent variable here is the angle at which the ball is launched. You may also include the letter that you use to represent this physical quantity. I'm going to use a letter theta, right? It's better, it's a good practice. Now, what is the dependent variable? When you change the angle, what is affected? Range of the ball is affected, right? Range of the ball. So what is the letter that I'm going to use for range? Let's say I'm going to use R, or you may use X also, because that is horizontal distance, right? Now you may ask me a question, why am I writing these letters here? Because later when I draw the table to plot to represent my data, instead of writing the full phrase, I simply use the letter theta, because already I introduced the letters here, right? That's the reason. Now, in doing this experiment, we need to keep some variables constant. What are those variables? Let's read further part of the question. The apparatus available includes a flexible channel as shown in figure 4.1. Don't worry about this figure. I will show you this figure later, okay? Or you may use your text booklet, which can be bent at different angles. So you have a flexible channel, and then you have a selection of balls, each of different diameter and mass. Now let's put it like this, children. You see, you are going to find out how varying angle affects the range of the ball, right? Can you use different balls to do the experiment for different times to find out the correlation? Is it a good method? Of course not. You need to use the same ball, right, of same diameter and of same mass. So those are the variables to be kept constant. So the variables to be kept constant for this experiment planning is the diameter of the ball, and then mass of the ball. So see, we can easily find out these things from the question, right? Maybe some of you may think about, what about the material of the ball, right? How about a cork ball, tennis ball, or a rubber ball, right? So you may use that, you may write that also, material of the ball, right? So these are the three different types of variables in our planning. Now, let's use another paper. Let's do another paper also from March 2022. So here in this question, a student investigates heating of water using an immersion heater. So what is an immersion heater? What if I don't know about immersion heater? Don't worry, already it is there in the question paper. Immersion heater is an electrical heater that can be placed directly into the water to heat the water. When you turn on the switch of the immersion heater, it starts generating heat, right? It converts energy into heat that heats the water directly. You can place this immersion heater inside the water. That's why it's called as an immersion heater, right? Now, they ask you to help the student by planning an experiment to investigate how one factor. So what did I tell you? When you come across this keyword plan, make a marker over there, because at the end of the experiment, this statement is going to help you to write the conclusion. Okay, so to investigate how one factor, you see the letter 1, the word 1 is given in bold fonts. Why? Because there are several factors that affects the rate at which the temperature of the water rises. So that's why they ask you to use any one factor that affects the rate at which the temperature of the water rises when heated using an immersion heater. Now, can we list out what are the factors that affect the rate at which the temperature of the water increases? Let's say I allow the current for different amounts of time, but later I'm going to find out the rate at which the temperature of the water rises, right? So that's not going to make sense. Fine. I may send different amounts of current. Let's say, when I turn on the heater, electric energy is converted into heat energy, right? If I send more current, then definitely more heat is produced, right? More heat is dissipated, which means water heats up quickly, right? So current is one of the factors that affects the rise in temperature of the water. Now, second factor, let's say volume of the water. If I use more volume of water, then definitely it takes a longer time for the more volume of water to get heated up, isn't it? So volume is one factor, current is another factor, right? So here I am going to use the factor current, which is my independent variable, electric current. So my dependent variable is change in temperature per unit time, that is rate at which. Remember this phrase, rate of or rate at in physics means with respect to time. With respect to time. Okay. All right, now I have found out my independent variable. What is my independent variable? Electric current. If you choose that to be volume of water, fine, that's up to you. So my independent variable here is electric current. And what is the symbol that I am going to use to represent electric current? I. What is my dependent variable? Rate at which water temperature rises. Water temperature rises. So what is the symbol that I'm going to use? Let's say del theta over del t. So del t, what is del t? In a particular interval of time, maybe 30 seconds, 60 seconds, 90 seconds, yeah. What is del theta? Where del theta is final temperature after I pass the current through the heater, right? The temperature rises to a final value. So final temperature minus the initial temperature. Now come to the third factor, variable to be kept constant. If I chose my independent variable to be electric current, then definitely one of my constant variables is going to be volume of the water, right? So volume of water. Can there be any other variables to keep constant? Let's say, okay, volume of water, then this time, right? Maybe I can consider that time of passage of current. I'm going to do the experiment for every 90 seconds, okay? Time of passage of current. And then I use, of course, electric power supply so that I make the heater to dissipate heat, right? So I need to keep the voltage of the power supply constant. Supply voltage to be kept constant. Then how do I change the current? I'm going to use a variable resistor for that case, for that purpose, okay? And it is also clearly given in the picture, in the figure, which I will show you later. So these are some of the variables that I can keep constant for this planning of my experiment, right? All right, I hope this three things are clear to you, right? So when you approach answering this question, don't forget to first start it with these variables in your papers. So what are the variables? Independent, dependent, and then variables to be kept constant. Find out these three things and write it down in your paper first, okay? I will talk about the apparatus in my second video. Okay, see you.